Hello, in this lecture we'll find out the length of line segment MN. In the drawing we have square ABCD. We know that one side of this square is equal to 12 units. That is to say AB equals to BC equals to CD equals to AD equals to 12 units. And inside the square we have a circle and a semicircle. The center of this circle is at point M. The center of the semicircle is at point N. And we actually want to find out the value of line segment MN, that is actually the distance between the center of the circle and the center of the semicircle. Okay, so first of all we will define the point of tangency of tangent AB with this circle. This point is point P. We will define the second point of tangency of this circle with the tangent BC as point Q. We will define the point of tangency of this circle with diagonal AC as point R. We will define the point of tangency of diagonal AC and the semicircle. This point as point S, and we will define this point as point T. And we also will define the length of line segment PB as A, and we actually have a rule. Will be rule number 1. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. I will read rule number 1 again. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. So actually, if we have here a point, this point is point P. Point P is not located inside the circle nor on the circle, but it is located outside this circle. Therefore, it is defined as an external point in relation to this circle. So if from the external point P we will draw two tangents to this circle, then so here we will have the first tangent, we define the point of tangency of the first tangent with this circle is point A. Then we will draw the second tangent to this circle. And we will define the point of tangency of the second tangent with this circle as point B, the point of tangency of the touching point. So here we have two tangents to this circle, tangent PA and tangent PB. Then according to rule number 1, the lengths of two tangents, that is to say the length of the first tangent is PA, the length of the second tangent is PB, and according to rule number 1, the lengths of two tangents from a common external point, that is to say from point P, that is a common external point to a circle, are equal. So according to rule number 1, PA is equal to PB, because of the fact that the length of those two tangents from a common external point to a circle, that is to say from point P to points A and B, the lengths of those two tangents are equal to each other. That is to say, PA is equal to PB. So whenever you have an external point to a circle and you draw two tangents to that circle, then the lengths of those two tangents will be equal to each other. In this case, PA is equal to PB. Okay? So here, if we focus on the external point, point B is an external point in relation to this circle. We have from point B two tangents to this circle. The first tangent is tangent BP. The point of tangency is point P, and the second tangent to this circle is tangent BQ. And according to rule number 1, the lengths of those two tangents are equal to each other. That is to say, BP is equal to BQ. So you can write down that according to rule number 1, BP is equal to BQ. Okay, BP equals to BQ according to rule number 1, but BP equals to A according to our definition. So from this equation, A equals to BP equals to BQ, we will derive that BQ is also equals to A. Okay, so we can write here that BQ equals to A. And we know that one side of square ABCD is equal to 12 units, so here we know that AB equals to 12 units. So if AB equals to 12 units, then AP will be equal to AB minus PB. Okay, AP equals to AB minus PB. So AP equals to AB, that is 12 units, according to what is given as the question, minus PB, that equals to A according to our definition. So in conclusion, we found out that AP equals to 12 minus A, AP equals to 12 minus A. Likewise, we know that BC is equal to 12 units, BQ equals to A, so QC will be equal to BA minus BQ. So QC equals to BA, that is, actually QC equals to BC. Again, QC equals to BC minus BQ. I repeat again, QC equals to BC minus BQ. But BC equals to 12 units and BQ equals to A. So we found out that QC equals to 12 minus A also. So we can write here that QC equals to 12 minus A. And if we focus on point A is an external point in relation to this circle. From point A, we have two tangents to this circle. The first tangent is tangent AP. Okay, the first tangent is tangent AP, and the second tangent from point A to this circle is tangent AR. And according to rule number 1, AP equals to AR. But AP equals to 12 minus A. According to what we have already found out, AP equals to 12 minus A. So from this equation, 12 minus A equals to AP equals to AR, we conclude that AR is also equals to 12 minus A. Here we can write down that AR equals to 12 minus A. Likewise, if you focus on the semicircle and at point A is an external point in relation to this semicircle. From point A we have tangent AS to this semicircle. The first tangent to the semicircle from point A is tangent AS, and the second tangent from point A to the semicircle is AD. AD is tangent to the semicircle at point D. Point D is the point of tangency. And according to rule number 1, whenever you have two tangents from a common external point to a circle, then the lengths of those two tangents will be equal to each other. That is to say, AS will be equal to AD. AS equals to AD, but it is given us the question that AD equals to 12 units. So you can write here that AD equals to 12 units. And from this equation, AS equals to AD equals to 12 units, we conclude that AD is also equal, that AS is also equals to 12 units. AS is also equals to 12 units. This is true according to rule number 1. Okay, AS is also equals to 12 units. So here, you can write down that AS is equal to 12 units, and from point C we have two tangents to this circle. The first tangent is tangent CQ, and the second tangent from point C to this circle is tangent CR. And according to rule number 1, the lengths of those two tangents are equal to each other. That is to say, CQ equals to CR. But CQ equals to 12 minus A, according to what we have already found out. CQ equals to 12 minus A. So from this equation, 12 minus A equals to CQ equals to CR. We will conclude that CR is also equals to 12 minus A. CR is also equals to 12 minus A. So we can write here that CR is equal to 12 minus A okay, and what is the value of RS? From the drawing you can see that RS equals to AS minus AR. AS minus AR. AS minus AR equals to RS. Again, AS minus AR equals to RS. But AS equals to 12 units. We have already found out that AS equals to 12 units and AR equals to 12 minus A. AR equals to 12 minus A. You see here that AR equals to 12 minus A. So in conclusion, we found out that RS equals to 12 minus 12 minus A. We will open the brackets here and we will get that RS equals to 12 minus 12 minus and minus is plus, so it is plus A, so 12 minus 12 is 0. So we found out that RS equals to A. RS equals to A, so we can write here that RS equals to A. And in the next step, I will present to you a new rule that is actually rule number 2. According to rule number 2, according to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So I read rule number 2 again. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if we have this circle and the center of this circle is at this point, we define the center of the circle as point O, and we also have tangent to this circle here. AB is tangent to this circle. At this point we define this point as point M. Point M is the point of tendency. The point of tendency of tangent AB with this circle. We will connect points O and M together by a straight line. OM is defined as the radius of this circle because of the fact that it starts from the center of the circle and ends at point M, that is the point on this circle itself. Therefore OM is the radius of this circle, so you can define it as R. So here we have the radius OM that is drawn to the point of tendency, that is to say, it is drawn to the point of tendency, that is the point of tendency of tangent AB. It is drawn to point M, that is the point of tendency of tangent AB with this circle. Therefore, according to rule number 2, the tangent AB will be perpendicular to this radius, that is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. So whenever you have a radius that is drawn to the point of tendency, like in this drawing, we have the radius OM that is drawn to the point of tendency, that is to say, it is drawn to point M, that is the point of tendency of tangent AB with this circle. Then the tangent will be perpendicular to the radius, that is to say, tangent AB will be perpendicular to the radius OM, that is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay, so this is rule number 2. Here we'll connect points M and P together by a straight line. Point P is the point of tendency of tangent AB with this circle, and PM is the radius of this circle because of the fact that it starts from the center of the circle and ends at point P, that is the point on this circle itself. Therefore, PM is the radius of this circle. So we have the radius PM that is drawn to the point of tendency, that is to say, it is drawn to point P, that is the point of tendency of tangent AB with this circle. Therefore, whenever we have a radius that is drawn to the point of tendency, then the tangent AB will be perpendicular to this radius, that is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees according to rule number 2. And we also know that the sum of all the angles inside a square are right angles. Angle ABC is 1 out of 4 angles inside square ABCD. Therefore, it equals to 90 degrees. So we can Right here that angle ABC is a right angle, it equals to 90 degrees. Here we will join points M and N together. We'll join points M and Q together by straight line. Again, MQ is the radius of this circle because of the fact that it starts from the center of the circle, that is to say from point M, and then it's going at point Q, that is the point on this circle itself. Therefore MQ is the radius of this circle. And we have the radius MQ that is drawn to the point of tendency, that is to say it is drawn to point Q, that is the point of tendency of tangent BC with this circle. Therefore, whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. That is to say, the tangent BC will be perpendicular to this radius MQ. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. So actually, we focus on quadrilateral PBMQ. In quadrilateral PBMQ, we have three right angles. Quadrilateral PBMQ has three right angles, 1, 2, 3. And the sum of three right angles is 90 times 3 is 270 degrees. Plus the size of the fourth angle, that is actually angle PMQ. In total, the sum of those four angles inside quadrilateral PBMQ must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We'll subtract 270 degrees from this equation, and we will get that angle PMQ is equal to 360 degrees minus 270 degrees is equal to 90 degrees. So we found out that angle PMQ is a right angle equals to 90 degrees. So we can write here that this angle is a right angle. So actually we found out that quadrilateral PBMQ has four right angles. Therefore, quadrilateral PBMQ is at least a rectangle. Okay, because any quadrilateral that has four right angles must be at least a rectangle. So we can write down that quadrilateral PBMQ is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. I'll write it down. Rule number 3. The opposite sides of a rectangle are equal to each other. So, according to rule number 3, in rectangle PBMQ, PB equals to MQ, PB equals to MQ, but we know that PB equals to A, PB equals to A, so from this equation, A equals to PB equals to MQ, we will conclude that MQ is also equals to A. So we can write here that MQ equals to A. Actually, it means that the radius of this circle equals to A. Likewise, we know that BQ equals to PM, BQ equals to PM, but BQ equals to A according to what we have already found out. So from this equation, A equals to BQ equals to PM, we will conclude that PM is also equals to A. So here PM equals to A. So actually we found out that the quadrilateral APBMQ is a square because of the fact that all of its sides are equal to each other. Okay? And in the next step, we will define the radius of the semicircle as B. That is to say, the radius of the semicircle, that is dn, is defined as B. Therefore, NT will be also equal to B, because it is the radius of the semicircle. And we know that DC is equal to 12 units because it is the side of square ABCD. So if DC equals to 12 units, then TC will be equal to DC minus DN minus NT. That is to say, TC will be equal to 12 minus B minus B. That is to say, it equals to 12 minus 2B. Okay, TC equals to 12 minus 2B. So here we will join points N and S together by a straight line. Here NS, line segment NS is the radius of the semicircle because of the fact that it starts from point N, that is the center of the semicircle, and ends at point S, that is a point on the semicircle itself. Therefore, NS is the radius of the semicircle, that is to say, it equals to B units. And according to rule number 2, we have here the radius NS that is drawn to the point of tendency. That is to say, it is drawn to point S, that is the point of tendency of tangent AC with this semicircle. Therefore, whenever we have a radius that is drawn to the point of tendency, then the tangent AC will be perpendicular to this radius, NS. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? And what is the value of diagonal AC? The value of diagonal AC equals to AR plus RS. The diagonal AC equals to AR plus RC. AR plus RC. Okay, AC, the diagonal AC equals to AR plus RC. AC equals to AR plus RC. But AR equals to 12 minus A. AR equals to 12 minus A. And we already found out that RC is also equals to 12 minus A. So in conclusion, we found out that AC equals to 12 minus A plus 12 minus A. 12 plus 12 is 24. Minus A is minus 2A. So in conclusion, we found out that AC equals to 24 minus 2A. AC equals to 24 minus 2A. We will focus on the right triangle ABC. Triangle ABC is a right triangle because of the fact that angle ABC equals to 90 degrees. In the right triangle ABC, according to the Pythagoras theorem, here the letters P and T is abbreviation for Pythagoras theorem. So in the right triangle ABC, according to the Pythagoras theorem, we will get that the square of the hypotenuse, that is AC square, must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to AB square plus BC square. So I repeat again. In the right triangle ABC, AB square equals to AC square equals to AB square plus BC square. We have already found out that AC equals to 24 minus 2A. Therefore, AC square will be equal to 24 minus 2A square. And it equals to AB square. AB is 12, so AB square is 12 square. Plus BC square. BC is also equals to 12, so it is plus 12 square again. So in conclusion, we found out that according to equation number 1, 24 minus 2A square equals to 2A square plus 2A square. 2A square plus 2A square is 2 times, actually 24 minus 2A square equals to 12 square plus 12 square. And 12 square plus 12 square is 2 times 12 square. So in conclusion, we found out that 24 minus 2A square equals to 2 times 12 square. Here we take a root out of this equation, equation number 1. And we get that according to equation number 1, 24 minus 2A equals to the square root of 2, and the square root of 12 square is 12 because the root cancels the square and we left only with 12. So in conclusion, we found out that 24 minus 2A equals to square root of 2 times 12. So here we will add 2A to this equation and subtract square root of 2 times 12, and we will get that according to equation number 1, (2A) equals to 24 minus square root of 2 times 12 So here we will divide the equation number 1 by 2, and we will get that according to equation number 1, a equals to 12 minus 6 times square root of 2. So we found out the value of a according to equation number 1, a equals to 12 minus 6 times square root of 2 units. In the next step, we'll focus on the right triangle NCS, the green right triangle NCS. We will implement the Pythagoras theorem on the right green triangle NCS. So in the right green triangle NCS, according to the Pythagoras theorem, we will get that the hypotenuse is NC, so the square of the hypotenuse is NC squared. It must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to NS squared plus CS squared. I'll repeat again, in the right green triangle NCS, by according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, NC squared equals to NS squared plus CS squared. And what is the value of the hypotenuse NC? The value of the hypotenuse NC, it is actually equals to, here we have NT plus TC. NT is B plus TC is 12 minus 2B square equals to NS square. NS equals to B, so NS square is B square plus CS square. Plus CS square. So we will have to find out the value of CS. What is the value of CS? It is very easy to see that CS or SC equals to RC minus RS. Again, RC minus RS equals to SC. I repeat again, SC equals to RC minus RS. SC equals to RC minus RS. So actually SC equals to RC, that is actually equals to 12 minus A, minus RS. We have already found out that RS equals to A. So in conclusion, we found out that SC equals to 12 minus 8 minus 8. This is to say it equals to 12 minus 2A. So we can write down that SC equals to 12 minus 2A. SC equals to 12 minus 2A. And we get that according to equation number 2, NC squared, it is actually equal to 12 minus B minus 2B is minus B. So NC equals to 12 minus B, and NC square will be equal to 12 minus B square, and it equals to NS square. NS square is B square plus CS square. CS equals to 12 minus 2A, and CS square will be equal to 12 minus 2A square. So here we want to find out the value of the missing variable B, that is the radius of the semicircle, and we have already found out that A equals to 12 minus 6 times square root of 2, so we can substitute A by 6 times by 12 minus 6 times square root of 2, so we get that the value of 12 minus 2A, it is actually equals to 12 minus 2A. That is to say, 2A is 12 times 2 is 24, minus 12 times square root of 2. We'll open the brackets here, and we'll get that it equals to 12 minus 24, minus and minus is plus, plus 12 times square root of 2. So in conclusion, we found out that 12 minus 2A equals to 12 times square root of 2. 12 minus 24 is minus 12. I repeat again, in conclusion, we found out that 12 minus 2A equals to 12 times square root of 2 minus 12. Okay, so we can substitute 12 minus 2A in equation number 2, this equation, by 12 times square root of 2 minus 12. We will do it now, and we will get that according to equation number 2, 12 minus B square equals to B square plus 12 minus 2A, according to what we have already found out, 12 minus 2A equals to 12 times square root of 2 minus 12 square. In conclusion, we found out that according to equation number 2, 12 minus B square is 12 square plus B square minus 2 times 12 times B, that equals to B square plus, here we'll take 12 as a common factor out of this expression, and inside the brackets we will have square root of 2 minus 1 all squared. So in conclusion, we found out that according to equation number 2, here we have B square on both sides of the equation, so B square will get cancelled, and we'll have here 12 square minus 24B equals to 12 square times square root of 2 minus 1 square. So it is actually 12 square minus 24 B that equals to, here we have 12 square on both, actually it is not, it is actually 124B that equals to 12 square, and we have here square root of 2 minus 1 square, square root of 2 minus 1 square equals to square root of 2 squared, that is 2, plus 1 squared, that is 1, minus 2 times square root of 2 times 1. Okay, so in conclusion, we have here 12 square minus 24b that equals to 2 times 12 square plus 1 times 12 square minus 2 times square root of 2 times 12 square. So here we have 12 square on both sides of the equation, so 12 square will get cancelled. And we're left with minus 24b is equal to, here we have 12 square is 144 times 2 is 288 minus 12 square is 144 minus 2 is minus 288 times square root of 2. So here we will divide this equation by 24 and we will get that according to equation number 2 minus b equals to 288 over 24. It is actually equals to 12 minus 12 times square root of 2. So here we will multiply equation number 1 by minus 1 and we will get that according to equation number 1 b, according to equation number 2, b equals to 12 times square root of 2 minus 12. We found out the value of b equals to 12 times square root of 2 minus 12. So here, in the next step, from point M, we will draw perpendicular, actually we will join points M and R together by a straight line. MR is the radius of this circle because of the fact that it starts from the center of the circle, that is to say from point M, and ends at point R, that is a point on this circle itself. Therefore, MR equals to, it is the radius of this circle, that is to say it equals to A. And we have here the radius MR, it is drawn to the point of tendency, that is to say it is drawn to point R, that is the point of tendency of tangent AC with this circle, and whenever you have a radius that is drawn to the point of tendency, like in this case, then the tangent AC will be perpendicular to the radius RM, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay, and we will, from point M, we'll draw perpendicular on RM. Again, we have line segment RM, and from point M, we will draw perpendicular on RM. So here, this angle will be equal to 90 degrees according to our construction. Okay, we have here two right angles, and then we will extend NS until it intersects with the perpendicular from point M. Okay. And we will define the intersection point between the perpendicular from point M and the extended NS as X. Actually, NS is the radius of the semicircle. NS is the radius of the semicircle. It is absolutely a straight line. NS is a straight line, and when we extended the straight line NS by straight line, it will still be a straight line. We extended the straight line NS by straight line, so NX will be still a straight line. So we can write down that NX is a straight line. Line segment NX is a straight line. I'll repeat again. Here, line segment NX is a straight line. And we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. I'll write it down. Rule number 4. The sum of the angles on one side of a straight line on one side of a straight line is equal to 180 degrees. I'll repeat again on rule number 4. According to rule number 4, the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line NX at point S, then according to rule number 4, the sum of the angles must be equal to 180 degrees. So which angles we have at point S on this side of the straight line NX? We have here 90 degrees. And we also have angle XS, angle XSR. So actually, according to rule number 4, the sum of the angles on this side of the straight line NX at point S must be equal to 180 degrees. that is to say 90 degrees plus angle XSR must be equal to 180 degrees in total. We'll subtract 90 degrees from this equation and we'll get that angle XSR is equal to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle XSR equals to 90 degrees. We can write here that this angle is a right angle, it equals to 90 degrees. So actually quadrilateral RMXS has three right angles. I write it down. Quadrilateral RMXS has three right angles, and the sum of three right angles is 270 degrees, plus the size of the fourth angle, that is actually angle MXS. In total, the sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We'll subtract 270 degrees from this equation and we will get that the angle that is missing, angle MXS, is equal to 360 degrees minus 270 degrees, it is equal to 90 degrees. So we found out that this angle is a right angle, it equals to 90 degrees. So therefore quadrilateral RMXS has four right angles, and any quadrilateral that has four right angles is at least a rectangle. Okay, so we can write down that quadrilateral RMXS is at least a rectangle, and we know that according to rule number 3, the opposite sides of a rectangle are equal to each other. That is to say, RM equals to XS. RM equals to XS according to rule number 3. RM equals to XS according to rule number 3. But RM is the radius of the circle, that is to say it equals to A. RM equals to A. We know that RM equals to A, it is the radius of the circle. From this equation, A equals to RM equals to Sx, we will derive that Sx is also equals to A. Sx equals to A. And I hear that Sx equals to A. Likewise, in rectangle RMXS, we know that MX must be equal to RS. MX must be equal to RS. But we have already found out that RS equals to A. RS equals to A. So from this equation, this is according to rule number 3, of course. From this equation, MX equals to RS equals to A, we will conclude that MX is also equals to A. MX equals to A. And actually we found out that quadrilateral RMXS is not a rectangle, but it is a square. Why? Because all of its sides are equal to each other, they are equal to A. In the next step, we will focus on the right triangle, triangle MXN. On the right triangle, triangle MXN, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is mn, therefore the square of the hypotenuse is mn squared. And it equals to the sum of the squares of the perpendiculars. That is to say, it equals to mx squared plus nx squared. Okay, so we'll focus on the right main triangle, triangle MXN. According to the Pythagoras theorem, mn squared equals to mx squared plus nx squared. So mn is the missing variable, the variable that we are looking for. So we leave it as it is. It equals to mx squared. Mx equals to a. Therefore, mx squared is a squared plus nx squared. Nx is a plus b, therefore nx squared will be equal to a plus b squared. So actually, in conclusion, we found out that according to equation number 3, mn squared equals to a squared plus ab squared. But we have already found out that the value of a, it is actually equals to a equals to 12 minus 6 times square root of 2, and we already found out that b equals to 12 times square root of 2 minus 12. Okay, and what is the value of a plus b? A plus b, it is very easy to see that if you add a to b, here 12 will get cancelled, and we're left with 12 times square root of 2 minus 6 times square root of 2, it equals to 6 times square root of 2 units. Now we put the values of a and b inside equation number 3, and we will get that according to equation number 3, mn squared, the missing variable, the variable that we are looking for in this question, that is actually the distance between the centers of the semicircle and the circle, equals to a squared. A is 12 minus 6 times square root of 2 squared, plus a plus b. We already found out that a plus b is 6 times square root of 2 squared, a plus b squared. So here we will get that mn squared, the missing variable in this question, equals to 12 minus 6 times square root of 2. It is 12 squared. 12 squared is 144 plus 6 times square root of 2 squared. 6 times 6 is 36. Square root of 2 squared is 2. 36 times 2 is 72. Minus 2 times 12 times square root of 2 plus, again, 6 times square root of 2 square is 36 times 2, that is 72. So in conclusion, we found out that according to equation number 3, mn squared equals to 144. 72 plus 72 is 144. 144 plus 144 is 2 times 144 plus we have here it is actually we got here a square plus b square minus 2 times a times b. It is actually 2 times 12 times square root of 2 times 6. So here 2 times 6 is 12 and 12 times 12 is 144. So we have here 144 times square root of 2. So here we will get that we will take here 144 as a common factor. 144 is a common factor. So inside the brackets, what is left from this expression is 2. What is left from this expression after we took 144 as a common factor? It is actually minus. Here we have minus. So it is minus square root of 2. This is the value of mn squared. We'll take a root out of this equation and we'll get that mn equals the square root of 144 is 12 times the square root of 2 minus square root of 2. So in conclusion, we found out that mn, the distance between the centers of the semicircle and the center of the circle, is equal to 12 times square root of 2 minus square root of 2. That is actually, in terms of numbers, it equals to 9.18 units. I'll repeat again. The answer to the question is that mn, the distance between the centers of the semicircle and the center of the circle, mn is equal to either 12 times square root of 2 minus square root of 2, or in terms of numbers it equals to 9.18 units. Okay, here the distance between the centers of the the circle and the semicircle is equal to about 9.18 units. Okay, so now I'll summarize the lecture. Actually, we have here square. We have here square ABCD, and inside this square, we know that one side of square ABCD is equal to 12 units. Inside this square, we have a semicircle and a circle. And we know that the center of the semicircle is at point M. The center of this circle is at point M. And we want to find out the distance between the centers of the semicircle and the circle itself. That is actually the length of line segment MN. Okay, so first of all we defined the touching point of tangent AB with this circle is point P. We defined the point of tangency of tangent BC with this circle is point Q. We defined the point of tangency of tangent AC with this circle is point R. We defined the point of tangency of tangent AC with this semicircle as point S. And we defined this point as point T. Then we defined PB as A. And because of the fact that AB equals to 12 units and PB equals to A, therefore AP is equals to AB minus PB, that is to say it equals to 12 minus A. Then I presented to you a new rule that is actually rule number 1. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. What is the meaning of rule number 1? The meaning of rule number 1 is that if we have this circle and we have the external point, point P. Point P is an external point because it is not located inside this circle, not located on this circle, but it is located outside the circle. Therefore, point P is defined as an external point in relation to this circle. So if from the external point P we draw two tangents to this circle, the first tangent is PA, the touching point of the point of tangency of the first tangent with this circle is at point A. The second tangent is PB, the point of tangency of the second tangent with this circle is at point B. Then according to rule number 1, the lengths of those two tangents that are extended from the same point, common external point, point P, the length of those two tangents are equal to each other. That is to say, PA equals to PB. So whenever you draw from a common external point two tangents to a circle, then the lengths of those two tangents will be equal to each other. In this case, PA will be equal to PB. So here we implemented the rule in our drawing. We have here, if we focus on at point B, it is the external point in relation to this circle. From point B, we have two tangents to this circle, tangent BP and tangent BQ. And according to rule number 1, the lengths of those two tangents are equal to each other. That is to say, BP is equal to BQ. Okay, here, according to rule number 1, BP equals to BQ, but PB is equal to A according to our definition. From this equation, A equals to BP equals to BQ, we conclude that BQ is also equal to A. And here, what is the value of QC? QC equals to BC, that is 12 units, minus BQ, that is A. So in conclusion, QC equals to 12 minus A. Then, okay, so here AP equals to AB minus PB. Okay, so we already found out that AB equals to 12 minus A. And then we focused on, we know that QC is equals to BC minus BQ. Here we have we found out that QC equals to BC minus BQ, that is to say, it equals to BC, that is 12, minus BQ, that is 8, that is to say QC equals to 12 minus A. Okay? So, what is the value of AP? AP equals to, here, AP equals to AR here AR. So what is the value? We know that if we focus at point A, from the example point A, we have two tangents to this circle. We have tangent AP and tangent AR, and according to rule number 1, they are equal to each other. Here, AP is equal to AR according to rule number 1, but we have already found out that AP equals to 12 minus A, so from this equation 12 minus A equals to AP equals to AR, we conclude that AR is also equals to 12 minus A. Here AR equals to 12 minus A. Then we focus on the external point, point A. Point A is an external point in relation to the semicircle. From point A we have tangent AD to the semicircle, and we have tangent AS to the semicircle, and according to rule number 1, they are equal to each other. That is to say, AS is equal to AD, but AD is equal to 12 units. It is the one side of square ABCD. So from this equation, AS equals to AD equals to 12, we conclude that AS is also equals to 12 units. Here AS equals to 12 units. Okay? Then, if you focus on point C is an external point in relation to this circle. From point C we have tangent CQ, this is the first tangent, and we have tangent CR, this is the second tangent. And according to rule number 1, they are equal to each other. That is to say, CQ is equal to CR according to rule number 1. But we have already found out that we have already found out that CQ is equal to 12 minus A. So from this equation, 12 minus A equals to CQ equals to CR, we will conclude that CR is also equals to 12 minus A. Okay? And what is the value of RS? RS is equal to AS minus AR. RS equals to AS minus AR. Again, RS equals to AS minus AR. It equals to RS. Okay, repeat again. RS equals to AS minus AR. AS equals to 12. AR equals to 12 minus A. So here, 12 minus 12 minus A. We open the brackets and we got that RS equals to A. So this line segment, RS equals to A units. Then I presented to you rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. What is the meaning of rule number 2? The meaning of rule number 2 is that if we have this circle and tangent AB is tangent to this circle at point M, that is to say point M is the point of tendency of tangent AB with this circle, we have the radius OM that is drawn to the point of tendency. That is to say, it is drawn to point M, that is the point of tendency of tangent AB with this circle. Therefore, whenever you have a radius that is drawn to the point of tendency, Then according to rule number 1, the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay? So whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to this radius. We implemented rule number 2 in our drawing. We have here we joined points P and M together by a straight line. PM is the radius of this circle because of the fact that it starts from the center of this circle, that is to say from point M, and ends at point P, that is the point on this circle itself. Therefore PM is the radius of this circle. And we have the radius PM that is drawn to the point of tendency. That is to say, it is drawn to point B, that is the point of tendency of tangent AB with this circle. Therefore, whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to this radius. That is to say, tangent AB perpendicular to this radius PM. That is to say, this angle equals to 90 degrees and this angle will be also equal to 90 degrees. And we also know that the sum, all the angles inside the square are right angles, therefore angle ABC equals to 90 degrees. We join points M and Q together by a straight line. MQ is the radius of this circle because of the fact that it starts from point M, that is the center of this circle, and ends at point Q, that is the point on this circle itself. Therefore MQ is the radius of this circle, and we have the radius of this circle that is drawn to the point of tendency. That is to say, it is drawn to point Q, that is the point of tendency of tangent BC with this circle. Therefore, the tangent BC will be perpendicular to this radius MQ. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. So actually in quadrilateral PBMQ we have 3 right angles, and the sum of 3 right angles is 270 degrees, plus the size of the fourth angle. In total they must be equal 1 to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So the sum of 3 angles, that is 270 degrees, plus the size of the fourth angle, that is angle PMQ, in total they must be equal to 360 degrees. We subtracted 270 degrees from this equation, and we got that angle PMQ equals to 90 degrees. So we found out that this angle is right angle, it equals to 90 degrees. Therefore, quadrilateral PBMQ that is 4 right angles, it must be at least a rectangle. Any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So quadrilateral PBMQ is a rectangle, and we know that according to rule number 3, the opposite sides of a rectangle are equal to each other. That is to say, PB equals to MQ. But PB equals to A according to our definition. So from this equation, A equals to PB equals to MQ, we will conclude that MQ is also equals to A. Likewise, BQ must be equal to PM, but BQ equals to A according to what we have already found out. So from this equation, A equals to BB equals to MQ, we conclude here PB equals to MQ and PB equals to A. So from this equation we conclude that MQ is also equals to A, and and likewise we know that BQ equals to PM, but BQ equals to A. So from this equation, BQ equals to PM equals to A, we conclude that PM is also equals to A. Here we have A equals to BQ equals to MQ. From this equation, we conclude that A equals to PM also, PM equals to A. So we actually found out that quadrilateral PBMQ is a square because of the fact that all of its sides are equal to each other. Okay? So here we have Uh, in triangle ABC, the right triangle ABC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AC square equals to AB square plus BC square. What is the value of AC? AC equals to AR plus RC. AC equals to AR plus RC, but AR equals to 12 minus A, and RC also equals to 12 minus A. So AC equals to 12 minus A plus 12 minus A, that is to say, AC equals to 24 minus 2A. So if we know that AC equals to 24 minus 2A, then we implemented the Pythagoras theorem on the right triangle ABC. Okay, here the square of the hypotenuse is AC square, it must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to AB square plus BC square. Okay, so here AC equals to 24 minus 2A, so AC square will be equal to 24 minus 2A square, and it equals to AB square, that is 12 square, plus BC square, that is also 12 square. So 12 square plus 12 square is 2 times 12 square, and it equals to 24 minus 2A square. We took out of this equation number 1, and we found out that 24 minus 2A equals to the square root of 2 times the square root of 12 square is 12, because the root cancels the square and we left only with 12. So in conclusion, we found out that according to equation number 1, 24 minus 2A equals to the square root of 2 times 12. Here we added 2A to this equation and subtracted square root of 2 times 12, and we got that according to equation number 1, 2A equals to 24 minus square root of 2 times 12. We divided this equation number 1 by 2, and we finally found out that the value of A equals to 12 minus 6 times square root of 2 units. Then we focused on the right triangle NCS. We actually, first of all, connected, joined together points N and S by a straight line, and S is the radius of this semicircle, that is to say it equals to B. Actually, we define the radius of the semicircle as B. And we have the radius NS that is known to the point of tendency, that is to say it is known to point S, that is the point of tendency of tangent AC with this semicircle. Therefore, whenever you have a radius that is known to the point of tendency, then the tangent, that is to say AC, will be perpendicular to this radius. That is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. Therefore, triangle NSC is a right triangle because it has one angle that equals to 90 degrees. So in the green right triangle NCS, according to the Pythagoras theorem, we will get that NC square equals to NS square plus CS square. NC is the hypotenuse, so the square of the hypotenuse is NC square, and it must be equal to NS square plus SC square. Okay? Here, dN is the radius of the semicircle, that is to say it equals to B, and T is also the radius of the semicircle, that is to say it also equals to B, and DC equals to 12. Therefore, the value of TC will be equal to DC minus DN minus NT. That is to say it will be equal to 12 minus B, that is to say TC equals to 12 minus 2B. And then we also found out the value of RC, the value of SC. The value of SC or CS is equal to RC minus RS. CS or SC equals to RC minus RS. RC equals to 12 minus A. RS equals to A. So SC equals to 12 minus A, that is to say SC equals to 12 minus 2A. Okay? And then, so, SC equals to the hypotenuse NC equals to B plus 12 minus 2B, B plus 12 minus 2B is 12 minus B, so the square of the hypotenuse NC is 12 minus B squared, and it equals to NS squared, that is B squared, plus SC squared, that is 12 minus 2A squared. We open the brackets here, and first of all, we have here the only missing variable that we have here is B, and A is equals to 12 minus 6 times square root of 2, so the value of 12 minus 2A will be equal to 12 minus 2 times A, that is 12 minus 6 times square root of 2, that is to say it will be equal to 24 minus 12 minus square root of 2. We open the brackets here and we found out that 12 minus 24 is minus 12, and here minus and minus is plus, so in conclusion we found out that 12 minus 2A equals to 12 times square root of 2 minus 12. So we can substitute 12 minus 2A in equation number 2 by 12 times square root of 2 minus 12, we did it, and we got that according to equation number 2, 12 minus B squared equals to B squared plus 12 times square root of 2 minus 12 squared. We open the brackets here, and we got that 12 minus B squared equals to 12 squared plus B squared minus 2 times 12 times B. So it equals to B squared plus 12 times square root of 2 minus 12 squared. We took 12 as a common factor, we took out 12 as a common factor out of this equation, so inside the brackets we will have here, from this expression what is left is square root of 2, and when we took from minus 12 to as a common factor, what is left inside the brackets is minus 1. So here B squared in this side of the equation and B squared in the other side of the equation, so B squared will get cancelled. And what is left from equation number 2 after we cancel B squared, what is left, it is actually 12 squared. 2 times 12 is 24, so it is 12 squared minus 24B. That equals to 12 squared minus square root of 2 minus 1 squared. So we have 12 squared minus 24B, that equals to 12 squared, and 12 square root of 2 minus 1 squared equals to square root of 2 squared, that is 2, plus 1 squared, that is 1, minus 2 times square root of 2. So here we have 12 squared minus 24B equals to, we open the brackets here, and so we have here 2 times square root of 2 squared, plus 1 times 2 times 12 squared, plus 1 times 12 squared, plus 2 times square root 2, minus 2 times square root of 2 times 12 squared. We have 12 squared on both sides of the equation, so 12 squared will get cancelled. So in this side of equation number 2, we have minus 24B, that equals to, here we have actually 2 times 12 squared. 12 squared is 144, and 144 times 2 is 188. 144 times 2 is 288. Here, 12 squared is 144, minus 2 is minus 188. Here, times square root of 2. So here, we divided this equation by 24, and we got it minus B equals to 12 minus 12 times square root of 2. We multiplied the equation number 2 by minus 1, and we found out that B equals to 12 times square root of 2 minus 12. Okay? Then we actually we focused, we joined together points M and R by a straight line. MR is the radius of this circle because of the fact that it starts from the center of this circle, that is to say from point M, and ends at point R, that is a point on this circle itself. Therefore MR is the radius of this circle, that is to say it equals to A. and we have the radius MR that is drawn to the point of tendency, that is to say it is drawn to point R, that is the point of tendency of tangent AC with this circle. So whenever we have a radius that is drawn to the point of tendency, then the tangent AC will be perpendicular to this radius RM. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Then from point M, we draw perpendicular to RM. So this angle equals to 90 degrees. Then we extended NS until it intersects with the perpendicular from point M. And we define the intersection point between the extended NS and the perpendicular from point M as X. So we have here 1, 2 right angles, and here NS is the radius of the semicircle, therefore it is absolutely a straight line. NS is a straight line, and when we extended the straight line NS by straight line, then we got NX that is must also still be a straight line, because when you extend a straight line by straight line, it still must be a straight line. So NX is a straight line, and if we focus on this side of the straight line NX at point S, then the sum of the angles here must be equal to 180 degrees, according to the rule that the sum of the angles on one side of the straight line must be equal to 180 degrees. So if we focus on this side of the straight line NX at point S, the sum of the angles must be equal to 180 degrees. So which angles we have at this side of the straight line NX at point S? We have here 90 degrees plus the size of this angle that is actually angle RSX. In total, they must be equal to 180 degrees. Okay, that is to say 90 degrees plus angle XSR must be equal in total to 180 degrees. We subtracted 90 degrees from this equation, and we got that angle XSR equals to 90 degrees. This angle equals to 90 degrees. So in quadrilateral RMXS we have 3 right angles, and the sum of 3 right angles is 270 degrees plus the size of the 4th angle that is actually angle MXS. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral must be equal to 360 degrees. We subtracted 270 degrees from this equation, and we found out that the angle MXS equals to 360 degrees minus 270 degrees, it equals to 90 degrees. So we found out that this angle MXX equals to 90 degrees, therefore quadrilateral RMXS has 4 right angles, therefore it must be at least a rectangle. Okay? Okay, so, and we know that the opposite sides of a rectangle are equal to each other. Again, quadrilateral RMXS is at least a rectangle. The opposite sides of a rectangle are equal to each other. That is to say, Rm equals to Sx. Rm equals to Sx, but Rm is the radius of this circle. That is to say, it equals to A. So from this equation, A equals to Rm equals to Sx, we conclude that Sx is also equals to A. Sx equals to A. Likewise, Rs must be equal to Mx. According to the rule that the opposite sides of a rectangle are equal to each other, Mx must be equal to Rs according to rule number 3. But we have already found out that Rs equals to A. Here Rs equals to A. So from this equation, Mx equals to Rs equals to A, we conclude that Mx is also equals to A. So we found out here that Mx is also equals to A. Okay, then because of the fact that angle MXN equals to 90 degrees, therefore the green quadrilateral and the green triangle MXN is a right triangle because it has one angle that equals to 90 degrees. So we can implement the Pythagoras theorem on the right green triangle NMX. Okay? In green triangle MXN, According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is nm, the square of the hypotenuse is nm square. It must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to mx square plus xn square. Mn square equals to mx square plus nx square, according to the Pythagoras theorem. Mn is the missing variable that we are looking for. Mx equals to a. Mx square is a square. Nx is a plus b. Therefore, nx square is a plus b square. We have already found out that a equals to 12 minus 6 times square root of 2. B equals to 12 times square root of 2 minus 12. A plus b, it is very easy to see that if you add a plus to b, then 12 will get cancelled, and we're left only with 12 times square root of 2 minus 6 times square root of 2 is 6 times square root of 2. So in conclusion, we found out that a plus b equals to 6 times square root of 2. So here, in equation number 3, we have nn square equals to a square. A square is 12 minus 6 times square root of 2 square, plus ab square. A plus b is 6 times square root of 2, so a plus b square will be equal to 6 times square root of 2 square. So in conclusion, we found out that according to equation number 3, mn square equals to 12 minus 6 times square root of 2 square, it equals to 12 square, that is 144, plus 6 times square root of 2 square, that is 72. Why? Because 6 square is 36 and square root of 2 square is 2, so 36 times 2 is 72. Minus 2 times minus 2 times AB, that is minus 2 times 12 times 6 times square root of 2 plus B square, 6 times square root of 2 square, 6 square is 36 and square root of 2 square is 2, 36 times 2 is 72. So in conclusion, we found out that according to equation number 3, here we have 144, and 72 plus 72 is 144. So 144 plus 144 is 244, minus 2 times 6 is 12. 12 times 12 is 144. So this expression equals to minus 144 times square root of 2. So in conclusion, according to equation number 3, we have mn square that equals to 2 times 144 minus 144 times square root of 2. We took 144 as a common factor out of this expression, and inside the brackets what we will have from this expression, what is left is 2, and from this expression what is left is square root of 2. So in conclusion, we got that according to equation number 3, 144 times square root times 2 times minus square root of 2 equals to mn square. We took a root out of this equation, equation number 3, and we got that the square root of 144 is 12, and times the square root of 2 minus square root of 2. So in conclusion, we found out that mn, that is the distance between the centers of the semicircle and the circle itself, here mn equals to either 12 times square root of 2 times times 2 minus square root of 2, or in terms of numbers, mn equals to 9.18 units. Okay, I repeat again, mn equals to either 12 minus it equals to 12 times square root of 2 times 2 minus square root of 2, or in terms of numbers, mn equals to 9.18 units. Okay, thank you very much.